Okay, so in the second part of our today's class, we will study inshallah another important part of the sound wave, which is how sound travels. Because it's so important to know that how sound travels, that if this mechanism wouldn't be there present, we will not be able to talk or communicate, right? কথা বলতেছি আমার লিপস গুলো ভাইব্রেট করতেছে, আমি সাউন্ড জেনারেট করতেছি, বাট এই সাউন্ডটা তোমাদের কাছে ট্রান্সফার হচ্ছে না, অথবা আমি জানি না এটা কিভাবে ট্রান্সফার হচ্ছে। ডেফিনেটলি যে জানে এবং যে জানে না তারা সমান, রাইট? সো আমি যখন কথা বলছি, there is oscillation, vibration that actually generate oscillation through the air molecules or air columns. Through the air columns, it reaches our eardrum. When I talk, my eardrum, your eardrum, both of them gets the oscillation, right? So they oscillates and we hear the sound due to the phenomenon of the human body, right? And the color of human body. Anyway, so tahole in general, samra jodi bolis how sound travels, sound is a longitudinal wave, right? So its oscillation is along the direction of the wave propagation or wave energy transfer. Now, how does it work? It's pretty simple. If I made oscillation on this particular ruler, right? On this particular ruler, and if it oscillates, thank you. And if it oscillates, let's say it is oscillating in that direction. It's oscillating back and forth, back and forth, back and forth. Okay, so it's oscillating very high amplitude, with very high amplitude, right? So এরকম ভাবে যদি এই রুলারটা অসিলেট করতো, অনেক জোরে সাউন্ড প্রডিউস হতো, রাইট? অ্যাকচুয়ালি অনেক জোরে সাউন্ড প্রডিউস হচ্ছে, বাট তোমরা শুনতে পাচ্ছ? Why? Because it is above your audible range. So just imagine that I am oscillating the ruler and it is oscillating so high amplitude, right? খেয়াল করো আমি তোমাদেরকে অলরেডি কনফিউজ করে ফেলছি। হাই অ্যামপ্লিটিউডের সাথে কিন্তু ফ্রিকোয়েন্সির কোনো সম্পর্ক। ফ্রিকোয়েন্সি যদি এরকম হতো, this frequency is let's say more than 20,000 hertz. 20,000 hertz মানে কি? এক সেকেন্ডে 20,000 টাইমস আমি এদিকে নিয়ে গেছি, আবার এখানে আছি। এই মুভমেন্ট এত ফাস্ট, you see I'm moving. You see I'm moving? Now, you don't see much because its frequency is more than 20,000 hertz. It seems stationary to you. Actually, I'm not. Okay. So if the oscillation is, let's say, it is within the right, very fast. Right. Let's say it is within the audible range, right? And if it is within the audible range, let's say the frequency is 200 hertz. Okay. And what we do is we hit the ruler and it goes forward, backward, right? When it goes forward, try to understand, it should push the air column near to the ruler all the way, right? Throughout this, it should push the air column, right or wrong, Hassan? So once it pushed the air column gets compressed and they moved forward. So they are moving forward. Then I move the ruler back. That doesn't mean forward moved air column will come back. Rather, you'll see some empty, almost empty air molecules, which is very few air molecules are there coming backward direction. Coming in backward direction, or it has generated a rarefied region, which is very few number of air molecules. কেন এটা হবে? Because air molecules গুলো কেন backward দিকে খুব বেশি মুভ করবে না? Because it was within a momentum. Due to that momentum and inertia, that the column I have already compressed has moved forward, right? So once I push the ruler backward, এই কলামগুলো কিন্তু এখানে ওইটার সাথে একটু সামনের দিকে মুভ করার টেন্ডেন্সিটা থাকতে পারে। And at the same time, when I move the ruler back, then it is a tendency to go forward, backward. So it will not move that much. When the molecule move forward, right? There is a gap. এই গ্যাপটা জেনারেট হয়েছে কখন? যখন তুমি এটাকে মুভ করছো, রাইট? এই মুভমেন্টের জন্য যে এয়ার কলামটা এখানে জেনারেট হয়েছে with less number of air molecules, that will not move, that will be stationary for the time. And again, once you push, now here comes, there is a compression region and there was a rarefaction region. Now you pushed again, there will be a compression region again. So something like this, try to understand. If you push and you returns it back, so এই পার্টটা সামনের দিকে মুভ করছিল, তার পিছনে একটা rarefaction region, এটাও সামনের দিকে মুভ করা শুরু করছে। You pushed again, there is another compression moving forward. You understand? So through this series of rarefaction and compression, which is oscillation with the direction of waves propagation. We say this is along the direction. So you see, oscillation is in this direction: compression, rarefaction, compression, rarefaction, compression, rarefaction. It is all the way towards the ruler, right? It's through the ruler, right? We observe. তাহলে এই ডিরেকশনে যদি আমরা এনার্জি ট্রান্সফার হয়, এদিকে যদি অসিলেশন গুলো হতে থাকে, এটাকে আমরা বলি longitudinal. So through this series of compression and rarefaction, longitudinal wave has generated and it will move forward. Since it's moved in forward direction, and if it reaches our eardrum, then it will generate a sound and we will hear it, right? We will hear the sound. Anyway, so mainly actually এই আলোচনাটা এখানে করা হয়েছে, you see the rarefaction region, compression region, right? এখানে একটা tuning fork দিয়ে এক্সাম্পলটা দেখাচ্ছি. If tuning fork, if you hit the tuning fork, it will oscillate. Through this oscillation, it will generate compression and rarefaction. Now, from the compression and rarefaction region, you see that the middle of a compression region is maximum compressed. The middle of a rarefaction region is maximum extended. Right? Okay, and one more information. The distance between the center of a compression to the next compression is actually one wave. And the distance between the most rarefacted region to the next rarefacted region is actually again one wave. Clear? একটা rarefaction থেকে পরবর্তী rarefaction পর্যন্ত, পরবর্তী rarefaction middle পর্যন্ত এই ডিসটেন্সটাকে আমরা বলছি one wavelength. One wavelength, right? Clear? Afrin, Fatima?
Yes, sir.
এবার আমরা একটু পড়বো এটা, আমাদের হাতে 10 মিনিট সময় আছে, আমরা পড়বো, পড়তে হেল্প করবো ফাতিমা। ফাতিমা পড়ো। Sounds are vibration that travels through the air.
One second.
Take your time.
Sounds are vibrations that travel through the air or another material produced by vibrating objects. How can we picture the movement of the molecules of the air as a sound travels through? Figure 12.11 shows how the vibrations of a tuning fork are transmitted through the vibrations of a through the air. As a prong of the fork moves to the right, it pushes on the air molecules on that side, squashing them together. These molecules push on their neighbors, which become compressed, and which in turn push on their neighbors, and so on.
Carry on.
It is important to note that the individual air molecules do not travel outwards from the vibrating fork. The air molecules are merely pushed back and forth. It is the vibrations that travel through the air to our ears.
Right.
This
So
picture,
air molecules, hold on, Baba. Air molecules কিন্তু মুভ করে না। Air molecules গুলো জাস্ট ভাইব্রেট করে। আমি যেরকম আমার অবজেক্টটাকে সামনের দিকে মুভ করে পেছন দিকে নিয়ে আসলাম, এয়ার মলিকিউলস গুলো এনার্জিটাকে তার পেছনে মুভ করে আবার পেছনে নিয়ে যায়। So right, so they are transferring the compression region to the next, rarefaction to the next, এভাবে series of compression region, rarefaction regionটা জেনারেট হয় এবং এটা কি করে সামনের দিকে মুভ করতে থাকে। This picture of how a sound travels also explain why sound cannot travel through a vacuum. There are no molecules or other particles in a vacuum to vibrate back and forth. When a molecule to vibrate back and forth, not the energy to carry forward. If there is no energy carrier, then sound shouldn't be traveling. Figure 12.11, 12.11, they mean this one, this particular diagram. Yes, also shows another way of representing a sound. As a wavy line, rather like the trace on an oscilloscope screen, the crest on the wave match the compression and throws match the rarefaction, right? খেয়াল করে দেখো এখানে কিন্তু আমাদের crest এবং throws গুলো দেখো compression rarefaction এই রিজনটাকে শো করছে, right? As if the most compressed region has the highest amplitude, and as if the most rarefacted region has the again highest amplitude but the negative direction, right? So তারপর তারা কি বলতেছে? Okay, the crest on the wave match the compression and throws match the rarefaction. It is much easier to represent a sound as an up and down wave like this rather than drawing lots of air molecules pushing each other back and forth. Here we have used two different models to represent sound. Sound can represent করার জন্য two different model they use. What are the models? Number one, vibration traveling through a material. The particles of the materials are alternately compressed together and then rarefied as the sound passes through. Number two, sound as wave, a smoothie varying up and down line like the trace on an oscilloscope screen. The first of these models give a better picture of what we could see if we could observe the picture of the material through which the sound is passing. The second model is easier to draw. It is also explained why we talk about sound waves. The wavy line is rather like the shape of the wave of the sea. There is much more about sound wave and the other wave in chapter 14. So once we go there, we'll discuss. In between the compression and rarefaction areas in which the air molecules are less closely packed together or rarefied, the sound wave has been drawn so that the crest on the wave match the compression and the throws match the rarefactions. Thus, the wave presence represents the changes in the air pressure as the sound travels from its sources. So let's solve the question number 14 to finish the whole thing. What is the difference between a compression and a rarefaction? Why not 12, 13? 12, 13 discuss kore ni amra? Right. Thank you. 12, 13 তাহলে আমরা discuss করে নি আগে. 12 and 13, right? Why it is impossible for sound to travel through a vacuum? Because sound travels through a medium through oscillation, right? Sound needs to oscillate the medium. If there is no medium, how it will oscillate and how it will transfer the energy, right? Number 13. How could you convince a small child that when you speak, it is not necessary for air to travel from your mouth to the ear of a listener? How could you convince a small child? A small child ki convince kortei hobe. When you speak, it is not necessary for air to travel from your mouth to the ear of the listener. So first thing first.
Scream at him.
স্ক্রিম করলে কি হবে তুমি বলবা যে সে তুমি চিল্লায় কইবা যে তুই বুঝতে হবে তো তুই ক আমি বুঝতে পারছি ব্যাপারটা কি এরকম ভয় দেখাবা লাঠি নিয়ে এসে বলবা যে ক আমি বুঝছি ফাতিমা তো খুব ডেঞ্জারাস দেখছো ছোট বাচ্চার কানের কাছে চিৎকার দিবে বুঝছস তুই কি কোনো বাতাস পাইছস কানে না পাই নাই বাতাস যেহেতু তুমি পাও নাই তার মানে কি এটা সাউন্ড ওয়েভ ট্রাভেল করার জন্য বাতাস লাগে right? Like a moment আমি তোমাদের সাথে কথা বলতেছি. Do you feel any air at your air drum? No, right? Air drum এ কিন্তু আমাদের কোনো air pass করতেছে না বা move করতেছে না. So that also tells us that the molecules doesn't necessarily it has to move, right, from me to you. Otherwise,
so if I close my ears, feel like it.
Because it's through oscillation. My voice is oscillating the air molecule, and air molecule is oscillating your fingers, and your finger is telling your eardrum that something is going on. Do you understand? তাহলে আমরা একটু পড়ে নেই তাহলে আমরা ছোট বাচ্চাকে কিভাবে কনভিন্স করব ছোট বাচ্চাকে বুঝাবো যে if air flows we should sense it. Do you sense the air flow once I talk? No, of course. 14, right?
Last one.
What is the difference between a compression and rarefaction in sound wave? Illustrate your answer with a sketch. So এখানে যে ডায়াগ্রামটা আছে এক্স্যাক্টলি আমরা এটা এক্সপ্লেইন করব এবার কম্প্রেশন rarefaction নিয়ে একটু আগে যে এক্সপ্লেনেশনটা দিয়েছি এই এক্সপ্লেনেশনটা আমরা লিখব নাথিং স্পেশাল তো সামারি আমরা দেখে নিব তার আগে আমরা হোমওয়ার্কটা দিয়ে নিই হোমওয়ার্ক ইজ এন্ড অফ চ্যাপ্টার কোশ্চেনস ECQ or UOC questions. Okay, end of chapter question. Solve end of chapter questions of chapter 12. Group likhe dao ahad. Homework, solve end of chapter question of chapter 12. Okay, so are kono question bujho na erokom kono confusion anything? Afrin, Fatima?
Yes, sir.
Any question, Baba?
No.
Okay. Okay then. Thank you for today. Assalamualaikum warahmatullahi wabarakatuh.
Wow.